bits of it though, the finish here or Maclaurin series when we do it in calculus, because there's a link to calculus here as well, which we haven't seen, to form these things. But we're just going to look at how to move between our polar form, our Cartesian form, and now this form, because it has an I in it. What does that mean? So when we see, I'll take my example, something like this. Not equals, evaluate E minus I pi over 4. I don't know, why haven't I minus I? I'm just going to do pi over 4. Okay. Oh no, that's why. I'll stick with the minus. Okay, how do I evaluate this? How does this look in a different form? Yeah. So evaluate it would be get it down to Cartesian form. What would that look like? Okay, what can I do with this? Well, I go back and I look at this. And that will help me convert it into polar form. And then I'll convert it into Cartesian form. What is the angle? Negative pi over 4. Negative pi over 4. So this can be rewritten cosine negative pi over 4 plus I sine negative pi over 4. What's the modulus? Yes. There's 1, it's just 1. There's nothing there to say anything else. There's no number in front of this E. It's just 1. All right. So evaluate, we mean to get into Cartesian form. What quadrant is this in, if we wanted to sketch it? Which one? Yeah, we go this. So that's 45 degrees. So it's going to be, it won't reach the 90 degrees. It'll be here. Minus just means we go this way. Positive means we go that way. Minus means we go that way. Minus plus. Okay, so so you can do root 2 over 2 here or 1 over root 2, whichever you prefer. This is going to be, cosine will be in that quadrant is positive or negative? Positive. It's in this quadrant. Think of the x-axis for cosine. So x value would be positive and minus root 2 over 2i using pi over 4. Where do we get pi over 4 from? Or where do we get root 2 over 2 from? Our classic sine, cos, tan table. That's it evaluated, yeah. That is the value. Remember, that's a number. So that's it evaluated. Okay, let's go the other way. Let's go from a Cartesian form to Euler's form. Let's take, which one? A simple one. 1 plus I. I want to write it in Euler's form. So the first thing I do is, if you want to write it in Euler's form, you got to go, well, the first way we went this way. Now we're going back. We got to go back through polar form to get to Euler's form. In other words, you can kind of skip it, but you definitely need the angle, and you definitely need the modulus before you can write it like this. So what's the angle here? No. Sketch 1 and 1. 1 and 1. Pi over 4. 1 and 1, pi over 4. It's a what did you say, root 3 over 2? Oh, I just said root 3 over 2.
Yeah, she said root 2 over 2. It's just that's not an angle.
Yeah, that's not an angle yet. What's the modulus? Okay, the modulus is root 2. So if I want to write it in polar form, which we'll just stop at on the halfway point to get in there, that's a positive pi over 4. I sine positive pi over 4. That's in polar. Now we can write in Euler form. our original one had a modulus of 1, so there was nothing in front here. Now this does have a modulus of root 2. It's okay just to put the root 2 before the e. That's just where it sits. Because the e to the thing is only this part. So you'd be multiplying this by that. And it's e, I, and whatever the angle is, pi over 4. And that's it in Euler's form. So it went from Cartesian form, polar form, Euler form. Okay, I'll do one more. Yeah, the modulus is the modulus here, yeah, multiply here, and the argument is just the angle here. It's not that complicated. Okay, the how we got it is super complicated. Using it or converting through it, not that complicated. Okay. Yeah, what is I to the power of minus I?
Because we're multiplying I by itself, negative I times, which is a number that doesn't quite exist.
Okay. All right, we want to give our answer in Euler form, otherwise it wouldn't really, well, it mightn't be. So that's, any ideas here? You definitely can. Okay, we can apply this power somehow. Where have we seen applying powers recently? Maybe De Moivre's theorem last night when you were doing it. Maybe. Okay, let's write this in polar form, and then apply the power that way. Is that a decent idea? Okay, what is this as a, like, I'm going to just take this bit first. What is, that's 0 plus 1i, or 0 plus I. Okay. What's, if I were to sketch that on my real and imaginary, it just would be here, wouldn't it? What's this angle then? Pi over 2, yeah. The modulus is going to be just 1, because it's just, yeah. So I could write cosine pi over 2 plus I sine pi over 2. Are we happy with that?
And then we can De Moivre somehow.
Okay. So that now we can write in, and it will work going, yeah. Yes, I have so far, yes. Yeah. Okay. So that is still to the power of minus I. I just didn't write it. We might as well convert. So we'll see which one is the most useful to use now. This is in Cartesian form. This is in polar form. And let's convert it to Euler form and have a look at which one would be the easiest one to apply the minus I to. Considering we need the answer in Euler's form, we'll look at Euler's form. E to the I pi over 2 to the power of minus I, yeah?
Then you can multiply powers, can't you?
Yes.
Okay, that makes sense.
So applying a power to a power is pretty easy. You just use the rules. And that's a power raised to a power, so that's going to multiply that, isn't it? So minus, yeah, I times minus I, well, you can write the step minus I squared if you want. Applying it in, and what's minus I squared? I squared is minus 1, so minus plus 1. So it's e to the pi I, or pi squared. That's the answer.
Negative I is I to the 3 multiplied by I.
Sorry? You have been stuck because it looks so weird? Yeah. Well, the hint was